Hello learners, I will discuss igneous textures, processes and pathways with special reference to phaneritic textures. I have already discussed phaneritic textures. Now, I will discuss another variety of texture which is called phaneritic texture. In this case of phaneritic texture, the mineral grains are large enough to be visible with unaided eyes. Till now I was discussing about the texture which is seen under the microscope, but here in case of phaneritic texture, the mineral grains are visible by unaided eyes and are available in magmatic intrusions, reflect crystallization at low degree of undercooling. It also shows low rate of nucleation formed under plutonic conditions and emplaced on the surface due to upliftment. This texture is different from the previous texture in the sense that it shows larger grains visible by unaided eyes and formed by slow rate of cooling compared to the faster rate of cooling in the previous rock types. These types of textures, they are mostly found in the plutonic rocks. Plutonic rocks are those rocks which are formed in deep seated conditions and they imply slower rate of cooling, and over the time period these rocks they have been uplifted to the surface. Phaneritic texture is classified into two major groups based upon the grain size, the equigranular texture or pegmatitic texture. Equigranular texture where the grains are all of equal size. In case of pegmatitic texture, there is a difference in the grain size, large heterogeneously sized crystals are present. In case of equigranular texture, there is a variety of seriate texture in which grains range more or less continuously in size. The another variety of phaneritic texture, that is third variety of phaneritic texture, is inequigranular texture. Inequigranular texture is grains of unequal size, and based on unequality of the grains, inequigranular texture is again classified into two major types. One is porphyritic texture, the other one is picolitic or ophitic texture. Porphyritic texture can be defined as large grains or phenocryst embedded within fine grained ground mass. The fine grained ground mass is chiefly composed of microphenocryst. So, this texture is called porphyritic texture. The another variety of inequigranular texture is picolitic texture, and ophitic texture is defined as larger crystal called oci crust, which encloses smaller size crystals or grains. Now, porphyritic texture, phaneritic or glassy rocks which contain large more or less euhedral phenocryst embedded within fine grained or glassy matrix or ground mass texture is called porphyritic texture. Under the porphyritic texture, there is a variety of texture which is called vitrophoric texture. Phenocryst lying in a glassy ground mass, then we call it as a vitrophoric texture. I am showing a thin section of a East Pacific rise rock, which is also a basaltic rock. This entire field of view looking black is chiefly composed of glass, and in this glass there is only one crystal of plagioclase lying in this glass. This is black ground mass entirely composed of glass containing zoned plagioclase phenocryst crystal inside it. I have drawn the picture based on my observation. Plagioclase phenocryst embedded within glassy ground mass formed under plutonic conditions, subsequently ground mass crystallized under volcanic conditions as evidenced by flow structure. These are the flow structures. The lines which I have shown here, this is a hand drawn picture. These are the flow structures and fine dust in a glassy matrix. This is a glassy matrix and this glassy matrix actually contains iron oxides, which is black in color. It is dispersed in the form of dust. Porphyritic basalt, again I am citing an example of basalt. This basalt displays inequigranular phenocryst. This is actually inequigranular phenocryst. Large euhedral plagioclase phenocryst. Euhedral means well developed crystal with well developed crystal boundaries with inclusions of glass. This crystal includes black colored glass inclusions. Grain matrix of pyroxene, olivine, plagioclase, glass and iron oxide. They are there in the matrix. This forms the matrix. See another slide in this picture. Pyroxene phenocryst digested by later tachoblast. Tachoblast is a variety of phenocryst which is much larger than the phenocryst. We call it as tachoblast. So, here in this case pyroxene phenocryst digested by later tachoblast plagioclase. This is a plagioclase. This is actually a pyroxene phenocryst. Earlier it was a continuous pyroxene phenocryst. Later on it was digested by a plagioclase grain. Plagioclase is cutting across the pyroxene grain, and this plagioclase displays zoned structure and twinned crystal. This is actually, this shows twinning. These line like structure is called the polysynthetic twinning. So, this displays polysynthetic twinning as well as zoning. So, this plagioclase is lying, both these crystals, plagioclase as well as pyroxene crystal, lying in a fine grained ground mass of plagioclase and pyroxene crystals both. Here I would like to tell you, the pyroxene and plagioclase, they form ground mass, they form phenocryst also. So, the larger size crystals are there in the phenocryst as well as they are dispersed in the ground mass. So, the same mineral is disposed in two places, one as a phenocryst, the other one in the ground mass. Here in this section, the same mineral, the plagioclase in the form of phenocryst, pyroxene is also in the form of phenocryst, as well as these pyroxene and phenocryst, they are dispersed in the ground mass. So, there are two generations of minerals, one is larger size crystals of phenocryst, the other one is a smaller size of crystals which forms the ground mass or also called as microphenocryst. Now, what is the interpretation? How these porphyritic textures they have been formed? What is their petrogenetic interpretation? I will focus one by one. Ununiform cooling of plutonic magma bodies can create porphyritic texture. Two-stage cooling path cannot account for deep phaneritic rocks. Must have cooled slowly at ununiform rate. The rate of cooling is ununiform. Therefore, you have two size crystals. Phenocryst nucleate just above solidus temperature, then other minerals. Next is by isothermal reduction in water pressure, sudden drop in the water pressure, that also gives rise to porphyritic texture. Through two levels of volatile concentration, not by two stages of cooling. This view is a latest view. Phenocrystic textures is developed because of the two stage cooling. That is an old idea, but now the new idea is the two levels of volatile concentration, that is accountable for the development of porphyritic texture. The last one is continuous uniform cooling of the melt can produce porphyritic textures. So, these are the interpretations. If you see porphyritic texture in any unknown igneous rock, they may be the reasons accountable for their formation. Now, I will discuss another important texture which is known as picolytic texture. Picolytic texture is defined as a large crystal which is also known as oci crust. This oci crust encloses smaller randomly oriented crystals. See here, this is okai crust. This okai crust or large size crystal which encloses a smaller size crystal here. I am citing an example of ezolite. Ezolite is also a variety of igneous rock which contains okai crust of azurine agate, which encloses many colorless minerals. This is actually azurine agate and it contains many colorless crystals here. See another slide here. I have drawn based on my microscopic observation tinguite. Azurine okai crust encloses colorless minerals of nepheline. Well developed azurine shows abundance of volatiles, encloses nepheline crystals were formed before the formation of azurine crystal. Nepheline crystals first separated, causing enrichment of magma with volatiles and consequently well developed azurine crystals were formed. These are the interpretations based on the textures. Now, I am discussing a very specific variety of picolytic texture which is also known as ophitic texture. In this ophitic texture, the clinopyroxene completely or partly enclosed by plagioclase laths. There are varieties of ophitic texture and we classify ophitic texture into variety of textures such as ophitic texture. In case of ophitic texture, large pyroxene grains enclose small plagioclase laths. Subophitic texture, large plagioclase laths partially enclose pyroxene grains. Nisophytic texture, plagioclase larger and pyroxene interstitial. In this case, intergranular. In this case, pyroxene and or olivine both can be possible. Filling gap between plagioclase laths. Interstitial texture, glass occupy space between plagioclase laths, which I have already discussed before this texture. Hyalophytic texture, in this case interstitial texture with a large amount of glass. Hyalo means glass. The hyalophyletic texture, more glass and plagioclase occurs as tiny microlites. Dixitextic texture, in this case abundant gas cavities between plagioclase laths. Where from these gases have come? These gases have come from the escape of volatiles and the open spaces are left out in the form of cavities and the resulting texture is called as dixitextic texture. Now, I am discussing about the cumulates. Cumulates means collection of phenocryst at one place. Cumulate, interstitial growth of mineral between earlier ones and accumulated at the bottom of the magma chamber. See, cumulates once they crystallized in the magma chamber, because first mineral crystallized is olivine, magnetite or to some extent pyroxene, they are of high density minerals. So, they sink down to the bottom of the magma chamber and once they sink down to the bottom of the magma chamber, they form a layer. All phenocryst, they are settled at one place and we call it as cumulates. Cumulates may be of orthocumulate. Orthocumulate means cumulate texture with other mineral occupy interstitial areas. Suppose you have pyroxene, in between pyroxene you have olivine crystal. So, that kind of rock texture is called orthocumulate texture. Adcumulate is another variety of cumulates. Cumulate texture in which early cumulate minerals grow to fill pore spaces. Whatever pore spaces are there in the rock, that space is occupied by the crystals. Mesocumulate, intermediate between ortho and adcumulate. This kind of texture is neither fully orthocumulate or fully developed adcumulate. It is intermediate between the preceding two textures. I will show you all these textures with the help of line diagrams here. Accumulated minerals in liquid. The minerals which are of heavier specific gravity, they sink down to the bottom of the magma chamber, and they are collected and deposited in the form of a cumulate here. This kind of texture is developed here. Here you have cumulates, but in between cumulates there are minerals of different composition, and this mineral composition is maybe plagioclase or maybe olivine, but this mineral is pyroxene. So, in a sense you have pyroxene phenocryst, and at the same time you have phenocryst of other mineral compositions such as olivine or maybe of pyroxene. So, this is orthocumulate. The next one is adcumulate, and the third one is picolytic or heteroadcumulate, which I have already discussed earlier. I will show you all these textures, how do they look under the microscope, citing an example of basalt. Here mega plagioclase, this plagioclase is larger in size, that is why I am calling it as a mega plagioclase. Its length is almost 6 millimeter in size with coliform zoning. This shows coliform zoning. Here in this case it shows coliform zoning, showing plagioclase clumping. Clumping means so many phenocryst of plagioclase, they are clubbed together and settled at one place. So, we call it as clumping of the mega plagioclase at one place. See another slide of a basalt. See, in one rock you may find different types of texture depending upon the different type of petrogenetic history. Plagiophyric texture, here see the phenocryst is of plagioclase. Here I see the pointer here, this is a plagioclase crystal. This plagioclase crystal size is 6 millimeter, which is quite big, with inclusions of pyroxene, plagioclase and magnetite. This plagioclase shows inclusions of pyroxene. This pyroxene crystal showing high order, second to third order colors. So, you have plagioclase crystal. Here in this plagioclase crystals, the pyroxene crystals are embedded within plagioclase crystal, as well as plagioclase crystals, they are embedded within plagioclase crystal, and glass is also embedded within the plagioclase crystal. So, this is a one variety of plagiophoric culmophoric texture. Then other one is gigantic pyroxene phenocryst. This is a gigantic pyroxene crystal. See the entire field of view, only one phenocryst is lying and the size is almost 3 millimeter size. It contains rod like smaller size plagioclase crystals. So, so many rod like plagioclase crystals embedded within the gigantic phenocryst of plagioclase. Next one is that is fourth one is glomeroporphyritic mafic ferric texture. Glomeroporphyritic means collection of phenocryst at one place. So, collection of clinopyroxene phenocryst at one place and giving rise to glomeroporphyritic texture. Now, another variety which I have already introduced earlier is the tachoblast. Tachoblast is much bigger than the phenocryst. When the phenocryst they grow in size much bigger in size, that can be visible by unaided eyes in a very fine grained rocks like basalt, we call it as tachoblast. Tachoblast, late phase pyroxene and plagioclase tachoblast. These are all pyroxene tachoblast. See here, they represent second order, high order polarization colors. This tachoblast also showing twinning here in this slide. Late phase pyroxene and plagioclase tachoblast observed attributed to autocatharesis. Autocatharesis is a process where the blastocyst follows the ground mass crystallization that consists of magnetite, small pyroxene and plagioclase laths. So, you have pyroxene within pyroxene as well as plagioclase within the pyroxene. Both the conditions are possible in this kind of tachoblast. I will sum up the entire discussion. I have already discussed phaneritic and aphaneritic textures, all varieties including ophitic, equigranular, inequigranular texture, ophitic textures, subophitic textures, how do they form, what are the processes they are held responsible for the formation of such a variety of textures in these rocks. Thank you, viewers.